Okay, so we're in section 6.2. You have already started a rule sheet, a rule page in your notes, and so you have two new rules from 6.1 that you have in your notes now, and you should be starting a new little section on that same page titled 6.2. There are two rules that you're going to learn for section 6.2. The first one is this. It is a base x raised to the m power divided by x to the n power is the same thing as x to the m minus n power. All right, so let's talk about this one. If the bases are the same, which they are, and it's a division problem, you're going to keep the base and you're going to subtract the numerators. I want you to see that the one on the top goes first on the left because we read from top to bottom and we also read from left to right, and the second one, the n that's on the bottom, goes second in the subtraction problem. It does matter what order you put them in, okay? So for example, if I have x to the fourth power divided by x squared, I want you to see that I brought my x over. I have the 4 minus 2 because 4 was on top, so 4 came first. The 2 was on the bottom, so it came second. It's a subtraction problem because it's division. I subtract 4 minus 2 and I get x squared as my final answer. So another example to point out that it does matter what order you put your numerator and denominator in is this right here. This is a completely separate problem, but if you mixed up your numbers, you may get the answer that you would get if your problem was completely different. So look at this one. It says x squared is your numerator divided by x to the fourth is your denominator. So 2 minus 4 gives you x to the negative 2 power. Okay, these are very different. X squared and x to the negative second power are not the same thing, and I'll show you that with the next example. So I did a negative here to point out our second rule, and our second rule is this. If you have a number raised to a negative power, it's the same thing as flipping that number to the negative power to the bottom or flipping it from the bottom to the top. You can go either direction with it, but you have to flip it into its opposite position, and then that exponent stays there, it just becomes positive. So let's look at an example. If I have x to the negative 2 power, I want you to understand that x is understood to be x over 1. So I'm going to flip it from the top down to the denominator, and that 2 stays there, but it becomes a positive 2 exponent. So this would be my final answer. Now let's say that we have another problem that I'm going to show you in just a second, that the x is actually a number. And here you go. So I have 3 to the negative 2 power. The negative tells me I need to flip this from the numerator to the denominator, right? Because it was up there, now it's going to the bottom, and so that's where this guy came from. And I know what 3 squared is. 3 squared is the same thing as 3 times 3, which is 9. So 1/9 is actually my final answer, okay? This is very different than just having 3 squared, because 3 squared is a whole number of 9. But if you have it raised to a negative power, it ends up being a fraction answer. So they are very, very different. That's why I was trying to make sure when you're doing this rule, that first rule I showed you, you keep them in the right order, because you could end up with a fraction answer when you really should have just a whole number. All right, so let's move on to some examples that we'll need to maybe talk a little slowly through. All right, x to the 8th divided by x to the 14th power. Okay, we take our x over because the bases match, they're both an x. 8 goes first, minus because of the divide sign, 14. I find this to be the same type of problem as x plus a negative 14. Signs are different, so I subtract and take the sign of the bigger number. And when I subtract 8 and 14, I get a negative 6. All right, so I say that's my final answer, but I remember that I learned this new rule that if I have a negative exponent, I'm not allowed to submit an answer with a negative. I have to go ahead and flip it over like it is here. So this is not my final answer. I need to keep going a little further. So I have x to the negative 6th. I'm going to have to flip it to the denominator, take the power with it, and so this becomes x to the 1 over x to the 6th power. Final answer. Okay, let's look at another one. Okay, the bases match, so I'm going to bring the x straight over. 18's on top, so it goes first, minus because it's a division problem, the 12. When I subtract here, I get a positive 6. How do I know? The signs are different. Subtract and take the sign of the bigger number. The bigger number was positive 18, and so I get a positive 6 for my final answer. All right, this one's a little more complex. There's more steps, more pieces involved. Okay. We've already been doing it, but I want to point out that anytime that you do a problem like this, when you rewrite it like this, whatever you're rewriting is in the numerator, okay? It's on top. If for some reason you end up, see, like I said, you did this problem here, we moved over, and I want you to see that all of this is in the numerator, and then if this happens to be a negative, we then would have to flip it to the bottom. And that's what we did over here. I showed you that we had to flip it to the bottom to get it to become a positive. So I want you to see every time we work through one of these, whatever I come out with over here is all in the numerator. If one of them's negative, the negative piece will drop to the denominator to become positive. So we're looking at this. The x's match, so I have 3 minus 10, and then the y's match, and I have 5 minus 2. Do you see how these go together based on the rule and these go together? The y's, it's subtraction because it's a division problem, but you still keep them separate. They're being multiplied between the two of them, but x and y can never be multiplied any closer than just touching the two letters together. So if I have 3 minus 10, that's the same thing as 3 plus and negative 10. Signs are different. Subtract and take the sign of the bigger number. Remember, everything that we're doing is in the numerator, okay? So I ended up with x to the negative 7th in the numerator, okay? I just brought my answer over here where on the bottom down here so it's in a more clear area. So here I have 5 minus 2, which is the same thing as 5 plus a negative 2. Signs are different. Subtract and take the sign of the bigger number. And so I ended up with y to the 3rd. This is my final answer, except for I need do a little simplifying. This guy is negative, so it has to go to the denominator for it to become positive. This guy is positive, so he's going to stay where he's at. So on top I have y to the 3rd. On the bottom I have x to the 7th. Final answer. Okay. I'm going to throw in some whole numbers because you do know how to use whole numbers, but it's going to start to confuse you just a tad when you start seeing all of these pieces here together. All right. I want you to see that 14 divided by 12 is one of the pieces that you have. And here's what I want you to do. You can look at these all as separate pieces. Okay? They're all touching up here, right? They're not as close as they probably could be, but there could be dots between them as well. But it's just, there's no add and subtract between them, which means it's all multiply, okay? Except for the top and bottom. Everything on top and bottom of these are being divided. So that's why I brought them down in separate pieces and you can look at them. I want you to look at that first piece, 14 divided by 12. 14 divided by 12 does not go evenly, but I can simplify it. I can divide the top and the bottom both by 2. Remember, to simplify, you have to divide by the same number on top and bottom. This becomes 6, this becomes 7. I circled what I have left over, okay? I want you to see that the 7 is positive, it's in the numerator, the 6 is positive, it's in the denominator. There's no rule that you just get to move one to the other, the top or bottom. If you have a fraction and 14/12 was your fraction and you simplified it, you still have a fraction of 7 over 6. They're never going to end up in the same, both in numerator, both in denominator, okay? The reason the powers do is because there's completely separate rules for those that you've learned today. All right, so let's look at the next piece. Remember that everything that we do all ends up in the numerator, so I have 10 minus 15. That's the same thing as 10 plus a negative 15. The signs are different. I'm going to subtract and take the sign of the bigger number, and so I end up with negative 5. So this whole piece is gone, and I end up with x to the negative 5th power. Okay? Do this last piece. I have y to the 7 minus 2. I'm going to mark them out because I've used it. 7 minus 2 is y to the 5th, and so I'm going to circle it. All right, this would be my final answer. I just have to put it together nicer, except for this guy is negative, so it needs to go to the bottom. So on top I have 7y to the 5th over 6x to the 5th. Remember, when you drop the x to the negative fifth power down to the bottom, it becomes a positive x to the fifth power. Okay? Okay, this one comes to a screaming halt, right? This is not looking like what we've been doing, except for it's the 6.1 rules, right? This is a power raised to a power, but then it's also being distributed to everybody inside, and so we've got to simplify this. So I want you to see that this is -2 times y to the fifth. I want you to see that fourth power goes to both of these pieces, and it also goes to that piece on the bottom. Okay? After I simplify this, I know that I have a whole number here and a whole number here. And they're going to be bigger numbers after I apply this fourth power to them, but numbers without letters attached to them can be simplified, just like we did over here in this piece, right? Here's the numbers, we brought them down and we simplified them. So we're going to do that, if possible, with the numbers in this problem. So I have -2 to the fourth power. -2 and -2 is a positive. -2 and -2 is a positive. Multiply together and I get positive 16. Okay. The next piece, I have a power raised to a power, so this becomes in the numerator only, right? Y to the 20th power. And the denominator, I have 5 times 5 times 5 times 5, right? 4 of them, this is what I see. And so that ends up becoming 625. All right, all that's gone. So the circle pieces are what I have left. 16y to the 20th over 625. If I can, I will simplify the 16 and the 625, and it does not look like I can, so 16y to the 20th over 625 is my final answer. Okay. All right, I've got 15x to the 5th, y to the 9th, over 5x to the 4th, y to the 5th. Okay, so they're as separate of pieces as you want to make them. If you want to rewrite them completely, we can. If you want to put dots between them, or if you think you can keep them separate, that's great. If you want to draw lines between them, I don't care. It doesn't matter. But you've got to focus on each individual piece. There are 3 separate pieces that need to be taken care of here. The first one are the whole numbers. And so I see that I can divide 5 goes into 5 one time, and 5 goes into 15 3 times. So my 1, ooh, this is messy. Let's try this again. The 1 on the bottom and the 3 on the top are what I have left over, and I marked out those whole numbers so I know exactly what I have. The next piece are my x's. Both of the x's have the same base of x. It's a division problem. I take the top number minus the bottom number, and so I have 5 minus 4. 5 minus 4 gives me 1. So I have x to the first power, or just x, right? X to the first is just x. It's in the numerator. And it's positive, so I don't need to drop it down to the bottom. The next one I have is y to the 9th minus 5. I'm going to mark these out because I used them. 9 minus 5 is y to the 4th. Y to the 4th is also positive, so it stays where it's at, does not need to drop down. The next thing that we need to do is we need to rewrite our answer. So I have 3x to the first, which is just x, y to the 4th, all over 1. Right? 1's the only thing down there. Well, anything over 1 is just itself. So this is my final answer. 3x, y to the 4th. Okay, one last one. Okay, we have x's and we have y's. It's a division problem. So I'm going to start with my x's. Here's my x. I'm going to subtract the top number minus the bottom number. I'm going to mark these out because I'm done with them. I know that 3 plus a negative 10 is the same thing as 3 minus 10. Signs are different. Subtract and take the sign of the bigger number. And so I end up with this as my numerator for x's. I move on to my y's. I subtract my numerator minus my denominator. 5 minus 2 is y to the third. Okay, so I have x to the negative 7, y to the third. The x to the negative 7 is negative, so it's got to go drop to the bottom. And so it becomes x to the 7th. So my final answer is y to the third, x to the 7th. Final answer. Okay. All right, that's all I have for this section. Actually, let's do one more that's a little more complex. That I can make sure that you know how to apply your exponents right. All of the rules together. Okay, so they're throwing in a challenge, right? They are throwing in this, which is from 6.1, right? This is a power raised to a power. And I want you to see that there's a power that belongs to the numerator and a power that belongs to the denominator. That 6th power doesn't belong to anybody on the bottom, nobody. But I do want you to see that the 6 goes to each piece inside. And I want you to see that it's a power raised to a power, which means I'm multiplying each time. So I have x, I have 3 times 6 gives me 18. I have y, 4 times 6 gives me 24. I have z, 5 times 6 gives me 30. Over the bottom ones, I have x, 5 times 4 gives me 20. I have y, 2 times 4 gives me 8. And then I have z, what times 4? Well, this is an understood 1. So 1 times 4 gives me 4. I want you to see just as clear as day that this, oops, sorry, my little circles there went with it. Okay, anyways, the red, I'll just put equal. So everything on the right side of that equal sign is a completely new problem. We are done with this problem. Okay, I don't need it anymore. I'm not using it. I've applied the exponents and we're only looking at what's on the right side. So now I'm going to use the rules, and I have x, I have 18 minus 20. Okay, 18 minus 20 is the same thing as 18 plus a negative 20. The signs are different. Subtract and take the sign of the bigger number, and so I should have x to the negative 2 power. Okay, kind of running out of space here, so let me try to rewrite this to make it a little bit easier. All right, the next one is going to be y to the 24th minus 8 power. Okay, when you subtract that, let's see. I don't know what problem I'm on anymore. 24 minus 8 looks like 16, I believe, a positive 16. Right, signs are different. Subtract and you'll take the sign of the bigger number. The bigger number was 24, so it's positive 16. If you don't follow me on that one, I'll rewrite it for you. 24 plus a negative 8. Subtracting 24 minus 8, and you got positive 16. So I'm done with these, and here's that number. The next one is going to be z to the 30th minus 4. Signs are different. Subtract and take the sign of the bigger number, and you end up with a positive 26. All right, so this is my answer. Unless I need to simplify it in any way. Okay, and I do see that this is negative, so it needs to go to the opposite of where it's at. It's in the numerator, so it needs to go to the denominator for it to become positive. And so when I move it, it becomes z to the positive 2. It's gone from here. And so if I have any more space, here's my final answer. Y to the 16, z to the 26th over z. Oh, sorry. Which one of these is y? Oh, x. This is x. God, if you weren't confused already, now you are. This x, I rewrote it with a z instead of an x. I apologize. So x was a negative 2 power. I moved it to the bottom, and so now I have x to the positive 2 power. Because when you move it across that division line, it becomes positive. So your final answer is y to the 16th, z to the 26th over x squared. All right, so make sure you do your Toyos for this section. That's all we have for this one.